guys, so today we're going to be solving we're going to be proving these two formulas, one of the most key and fundamental formulas. One of them is the Euler's formula and the Moivres theorem. Okay, so we're going to start with Euler's formula. All right, so Euler's formula, this is the relationship of an exponential complex with trig functions, cos and sine. So this is equal to cos theta plus e sine theta. Okay, so for you to show this, basically what you do is you you define a Taylor expansion of the exponential function, which is given by 1 plus x squared over 2 plus x over 3, 6 over 3 plus x to the power 4 over 24 plus dash 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 plus xn over n factorial, like that. Okay, so here we can just pause x to be equal to uh, I theta. So this means that e to the power I theta will have a Taylor series expansion of 1 plus I theta um, minus theta squared over 2. Then this will be also minus theta to the power 3 over 6, and then this will be plus theta to the power 4 over 24. We know that I squared is equal to negative 1, I to the power 3 is equal to negative I, and I to the power 4 is equal to 1 respectively. So therefore, if we x is equal to I theta, so if we try to raise I theta to the power squared, we find that we square the I, we will have I to the power 3, I to the power 4 in that order. Alright, so this continues going on until you have I theta to the power n over n factorial in that order. Alright, now we know that we also know that from this expansion, from this Taylor series expansion, we know that we can now group the imaginary terms together and the real terms together. So for example, ei theta will be equal to 1 minus theta squared over 2 minus theta 3 over 6, no, theta 4 over 6, this is supposed to be I, and then plus e, if we group the imaginary terms together, we're going to have theta minus theta 3 over 6 in that order. Yeah, then plus dash dash dash. So now we know that the Taylor series expansion of cos theta is equal to 1 minus theta squared over 2 plus theta to the power 4 over 6 plus 0 of theta to the power 4. And then we also know that the Taylor expansion of sin theta is equal to theta minus theta 3 over 6 plus theta 5 over 5 factorial plus theta to the power 5. So from this we can determine that this is cos theta and this is sin theta. Therefore, e I theta is given by cos theta plus e sin theta respectively. Hence, proved. So using Euler's formula, we can also show the Moivres theorem. So the Moivres theorem says that cos theta plus e sin theta raised to the power n is as good as cos n theta plus e sin n theta. So this is known as the Moivres theorem. Okay, theorem. Okay, now we know that from Euler's formula, we know that e to the power e theta is given by cos theta plus e sine theta. Therefore, if we raise e to the power theta, if we raise to the power n, this will be as good as raising cos theta plus e sine theta to the power n as well. Alright, now, so this can also be represented as n theta. So this is also equivalent to e I alpha, where alpha is equal to n theta, and we know that from Euler's formula ei theta is equal to cos alpha plus e sine alpha. So this is equal to cos alpha is n theta plus e sine n theta. Therefore, the left hand side is equal to cos n theta plus e sine n theta, which is equal to the right hand side cos theta plus e sine theta to the power n. So the Moivres theorem has been proved, hence proved. Now we've shown the Moivres theorem using Euler's formula, but now we can also prove the Moivres theorem using mathematical induction or raisonnement par excellence, as they say in French. So using mathematical induction, so the Moivres theorem says that cos theta plus e sine theta, everything raised to the power n, is as good as cos n theta plus e sine n theta. Alright, so we're going to use a mathematical induction. So we're going to look at the basic case, okay? Basic step. The basic step will be checking for n is equal to 1, so 0. So when n is equal to 0, so this anything raised to the power 0 will be 1. So everything will be 1. So the left hand side will be equal to 1. Then when n is equal to 0, the right hand side will be equal to cos 0 plus e sine 0. Okay, and we know that cos 0 is equal to 1, sine 0 is equal to 0, so this is going to be divided by 0, so this is going to be 1. Therefore, the basic step has been proved. So you can go on and show for n is equal to 1 and n is equal to 2 if you want, and this will prove itself. Alright, now that the basic step is proved, we're going to suppose that it is true for the n minus 1 step, the step just before the nth step, then prove for the nth step. Alright, so if it is true, if I suppose that it is also true for n minus 1 step, which means that cos theta plus I sine theta, everything raised to the power n minus 1, because we're supposing that the n minus 1 step is true, is equal to cos, we're going to drop the same n minus 1, multiply this by theta plus I sine n minus 1 theta. Alright, so using this, we're going to try and prove that it's also true for the nth step, I sine theta to the power n is equal to cos n theta plus I sine n theta. So we're going to use this in order to prove this. Alright, so we know that from our our case that we've supposed, we know that from our hypothesis, this is a hypothesis. So from our hypothesis, we know that cos theta plus e sine theta the power n minus 1 if multiplied by cos theta plus e sine theta, this will be equal to so we can now multiply this, we can now multiply by with this term. Alright, so the right hand side will be the same as cos n minus 1 theta plus e sine n minus 1 theta will be multiplied, everything will be multiplied by this term cos theta as well plus e sine theta. So notice that if you multiply these terms, you're going to have to the power n. So we're going to see what's going to happen here. We're going to see now if this will be equal to this term. Alright, now for us to be able to show that, we have to expand this term. Alright, so you should expand these terms and then equate them, group the imaginary terms together and the real terms together as well. Alright, so now, so what we do basically is, I'm going to try and multiply cos theta with everything. So if I multiply cos theta with everything, I'm going to have cos n minus 1 theta multiplied by cos theta. Okay, let me just change the color. Then I'm also going to have plus e sine n minus 1 theta, then cos theta. Okay, then the other terms will be, now I'm going to multiply by this term throughout. So I'm going to have cos n minus 1 theta, so the e will be here, and then I can say sine theta here. Okay, and then I also have the e multiplied by the e, this will be negative, then the sine theta, so I'm going to have sine n minus 1 theta sine theta. Alright, and then once we have this right hand side term, we can now group the e terms together and the real terms together. So if I were to group the real terms together, I'm going to have theta cos theta, then I'm also going to have minus sine n minus 1 theta sine theta. Okay, and then this is going to be added to the imaginary terms, so I'll factorize by I. Okay, so the first term will be sine n minus 1 theta cos theta. Okay, and then the other imaginary term is here, and then plus this is going to be cos n minus 1 theta sine theta. Alright, now you should make an observation. Observe that this is none other than cos n theta. Okay, so we're now going to show, let me show you why this is none other than cos n theta. Alright, so this is none other than the multiple angle formula of cos. So the first angle is n minus 1 multiplied by theta, which is cos n theta minus theta. This one, this is the first angle. So there's a minus, which means there's plus. Okay, then you're going to have the second angle, which is theta. Okay, the second angle is theta. Okay, so this is going to give you cos, this theta and theta will cancel, so we're going to have cos n theta. Alright, okay, so here you've got the first angle, the second angle, the first angle, the second angle, which means, and here we've got cos and sine. So cos will have a compound angle, have the first angle, then there's a minus, which means there's a plus here, then the second angle. Then you find that they'll cancel, you have cos n theta. Therefore, we've shown that this part is equal to cos n theta. Alright, so we're also going to show this part is equal to sine n theta. So it's also very simple. So this is the first angle, this is the second angle, this is the first angle, and this is, and we've got cos sine cosine. This means that this is sine n minus 1 n theta. If I multiply by theta minus theta, then I'll have plus theta. Okay, so this means that this is none other than sine n theta. Therefore, the right hand side, from the right hand side, I can conclude that this part is equal to cos n theta, the second part plus the second part, which is equal to sine n theta. Therefore, from what we knew, cos, the left hand side we had cos theta plus I sine theta, everything you multiply by n minus 1, so we had to multiply by cos theta plus e sine theta. So this term is none other than, the left hand side will give us, if we multiply this by this, we're going to add the powers together. So we're going to have cos theta plus e sine theta, everything raised to the power n, is equal to cos n theta plus e sine theta n theta. Therefore, we've shown by mathematical induction, hence proved. So just a reminder, we know that cos a plus b is equal to cos a cos b minus sine a sine b, and we know that sine a plus b is equal to sine a cos b plus cos a sine b. So there will be a point where we'll have cos n minus 1 theta cos theta minus sine n minus 1 theta sine theta. So this means that we're using the first one. Okay, so if we're using the first one, it can only mean that, this is a and this is b. Okay, so this will be cos a n theta, if you multiply, minus theta plus b theta. So this is going to be, this and this will cancel, cos n theta. Yeah, so basically we do the same for the second part, for the sine part. So basically what you do is you work with the right hand side, you multiply by this term, you expand, and you correct the imaginary terms together. And once you do that, and then you can apply these multiple angle formulas in order for you to prove. Therefore, I've given you two ways in which you can show the Moivres theorem. We can use Euler's formula, and we can also use raisonnement mathematical induction, which is raisonnement par récurrence in French. Thank you very much. See you next time.